So as you're getting those things copied down, I'm going to give you kind of an overview of what we're going to do today, and I'll tell you a little story to set the foundation. But somebody came in first period and they looked at that and they went, "Oh wait, I thought we were done with all that. Didn't we take that big test?" Yeah, you took the big test. That was the theory part. Now we're getting into the practice part. And you guys don't get a lot of vocational ed. You know what that is?
No.
Vocational ed is where you learn what? Like hands-on, how to do a job, how to auto shop, how to do welding, home ec, all those kinds of things. So I'm going to give you some real practical, hands-on experience, knowledge that you can use to do some stuff, like building circuits. And just with the basic electric knowledge you've already gained and a little bit more that I'm going to give you in a couple lectures here, you can do quite a bit of damage, quite a bit of cool things. We talked about schematics already, and I'm going to give you definitions for these again today, but basically our lecture is going to deal with how do you go from a schematic, which is like a recipe, and how do you turn it into reality? Because the circuit boards, like the kind you guys will be dealing with, they've already been made, but I like you to know what's involved in making one of those. It's got all the little lines and little holes with copper on there. And what you're going to do is you're going to be putting your parts on that. We're going to get to that part tomorrow. You're going to be putting your parts and you're going to be making the electrical connection. But I want you to know how we go about doing that, how we take it from the recipe to reality, how we actually build a circuit. And we go through several stages. One of the stages is called making a board layout. So all these terms will make sense once you see how we build a circuit from scratch. I learned this all on my own. No one really taught me. And if I can learn on my own, I know you can learn it from a little bit of information that I give you. Then at the end of the period, I'm going to get your circuits out to you. We're going to be inventorying them. We're going to check and make sure that everything that's supposed to be in there is in there, and transferring them into little Ziploc bags. And then tomorrow we'll get into actually putting them in the board and constructing them. But I just thought you might find it interesting to hear how I got involved in electricity as a hobby. And it started one monsoon day in the summer long ago. I think I was, 10 or something like that. Like many kids, I was always fascinated with electricity. Some of you, I know I've heard you talk about it. You maybe open up the clock radio sometimes when it's broken and you say to mom or dad, "Hey, can I look at that as long as you're going to throw it out anyway?" You might say, "Sure." Other times you open up stuff when you don't ask, right? And then it just magically winds up broken. And parents can't figure out how. It's because you got inside and you were messing with stuff. Okay? Well, that is how I learned a lot. That's how I gained my interest. I didn't learn so much as I gained my interest and got really excited about electricity. Sometimes a little bit of knowledge is a dangerous thing. I got really curious about electricity. And I remember on this one summer afternoon, my sister and I were the only ones that were home. She was kind of looking out after me. And she wasn't in her room, so I decided to wander in her room. I don't know, something was just pulling me into her room. I was drawn to it. Don't know why. I went into her room, and across the wall I saw the outlet. I was just drawn to it. I was just excited. And in my hand I had...
Paper towel.
No, close.
Paper clip.
A screwdriver. I don't know what I was originally planning on doing. Maybe it was to take off the outlet plate and look inside. I had done that. You've done that? Okay. Well, I wandered over to the outlet, and I remember for some reason I just stuck the screwdriver in the outlet. Well, long story short, I wind up 15 feet away on my butt, staring at my hands, and there's blood on it, and not a cut. And I realized, oh, the lights are out. Right away, I could hear my sister calling my name, because if anything went wrong with the electricity, it probably was me. And I'm staggering down the hall with my bloody hands in my screwdriver. And I look out, I see the neighbors. Their lights are out too. And so are those guys. Now, it might have just been a coincidence. It might have had something to do with the storm. I don't know. But I was fascinated. I was hooked with electricity. And so my parents, they wanted to focus that energy in a constructive way. So for one Christmas, they got me this guy. This is a modern version of what I had. This is the 201 electronic project kit. I had the 101. And now all those little doohickeys and doomagabis and things I saw inside the circuits that I didn't understand, now they were explained to me. I saw all the resistors and the diodes and the transistors and capacitors and ICs and transformers, all the parts we've already talked about in here. And I saw the names, so I started to become familiar with the names. And I realized that I could impress a lot of people very easily simply by following these plans that were shown inside the book. Okay? The book would have these little plans. It would show you how to connect different parts together, and you could follow the picture and connect the wires just like the picture shows, or you could just follow the numbers. It's like connect the dots. This says connect spring number 1 to 64. Well, each of the parts are connected to these springs. So if I want to connect parts together, all I have to do is bend the spring back, stick the wire underneath, and I could hook them up. Didn't require any special skills, just being able to connect the dots. And so I hooked up all these different circuits, and with these same ingredients, I could make a whole bunch of different things. Just like with, flour, sugar, salt, a few basic ingredients, you can make a whole bunch of different kinds of foods. I can make a whole bunch of circuits with the same ingredients. So I made metal detectors like you guys are going to make. I made sirens and radios and all sorts of different things using those same basic parts. And of course, as soon as I made it, I'd go show my parents, look what I did. Ooh, that's impressive. How'd you do that? Well, they didn't know how simple it was. Okay, it was real simple. But the same parts could just be rewired. And it got a little messy. Some of the circuits are pretty complicated. They have a lot of connections. Like look at this one. Okay, with the number of wires I had to connect for that. So it got a little messy. But I might make a circuit that I really like a metal detector, and I'd go, well, yeah, that's a metal detector, but this is kind of big and bulky to carry around. Wouldn't it be nice to have something like the one you're making to get it to smaller size? Head up, Monet. So I got motivated to do something smaller. By the way, Jeff brought in vacuum tube. That's a small vacuum tube, by the way. There's many that are much bigger than that. So that's like an antique now. You can credit that for our early computers, which led to our modern computers. In any event, I had this big board and I wanted something smaller. So I looked at the parts that I had involved, and maybe there were 6 parts. And I thought, I wonder if I could just get those parts. And you can. And they weren't that expensive. 50 cents for this, $1 for that. So I'd go to Radio Shack, which I ended up working at later on, and I bought all the parts. And then I just hooked them together by twisting wires together. Didn't have a clue why it worked, how it worked. I just followed the recipe. Okay? Head up, please. So I had this big blob of wires and parts and electrical tape, but it worked. It wasn't very reliable. One wire gets pulled out and it doesn't work. Okay? Which brings up an interesting point. The circuits we're going to be building today and for the next several weeks. How accurate do you think you have to be? How precisely do you have to follow my directions? 100%. If you follow 99.9% of my directions and only miss one tiny little detail, guess what? It's not going to work. Okay? Every wire, every part has to be there. Close is not good enough. We're not playing horseshoes here. So I kind of like that about circuits, You know that if it works, you got 100%. You did everything exactly the way you were supposed to. So eventually I would make these circuits that were just a mass of wires and parts, not very reliable, and somebody introduced me to this idea of making circuit boards. They explained that we could replace all those wires like I have here. I only have 3, but if I have a bunch, I could replace them with connections of copper that are a part of this board. This is what we call the circuit board. So all these lines of copper, they're called traces. We'll talk about that. They replace the wires and give me a connection. So I started to make circuit boards. And I'm going to show you several methods that they use for that. But we're trying to get from the schematic to the circuit board. And there's several steps to get to that point. Any questions before I go any further? Yeah, I'm going to show you a little bit later, too, some of the circuits that I built. But first of all, I want to get you... here we go. Familiar with the process. All right, a schematic. we already know a schematic is like an electronic blueprint. It's going to show all the parts and how they are to be connected. You should recognize some of these. What's this part right here? A resistor. And it even tells me a 100,000 ohm resistor. So I could write that down on my shopping list. Okay? And this is a capacitor. It tells me it's a 0.1 microfarad. So I can write that down. So I write up my shopping list based on the schematic. Then I go into the electronic store and I say I need a 100,000 K resistor. I mean 100K resistor. I need a 0.1 microfarad capacitor. I don't even know what all that means. But I could read it off the thing there. And my little book here that I had been working with, it started to teach me later on in the back. It got rid of the picture of the board and it replaced it with a schematic. So that's how I started to learn the schematic symbols. So I already knew what those parts were. All right, so then the next step, take my shopping list in, get the parts, and come back. I've got a plan, I've got the parts. Now I got to build it. The problem is a schematic shows you what's connected to what, but you can't build it the way the schematic shows exactly. Because here we can see a resistor. It connects here, and it connects over here. Now in reality, I could build that and have that thing just sticking up off of the screen right now. I could have it connecting here and here. But if it's laying down flat and that bare wire touches this bare wire, I'm making a connection. In a schematic, if there's a dot, that means there's an actual physical connection there. If there isn't a dot, like where this wire and this wire cross, there's no connection. You see what I'm saying? So even though this shows me how to connect this stuff, I couldn't build it exactly like you see that way, because if I put a wire and I put another bare wire on top of it like that, they're going to touch, they're going to connect, and those are not supposed to connect. So I have to change the plan a little bit. It's still going to connect to the same places, but maybe I'm going to run my resistor around this way and connect it there. You see what I'm saying? So that it doesn't cross that line. Because when I build it, in reality, I'm going to replace all these lines with pieces of copper. And the copper all lays flat on the board. So if one wire goes this way and one wire goes that way, they're going to be connected. Can't do that here. They're not supposed to be connected. So I sit down and I plan out the board layout. The board layout is what it's actually going to look like when you build it. And when you do the board layout, you have to consider how big are the parts. Like what part goes here? What does that look like? Got a little notch in the end and a whole bunch of connections. That's an IC. So I know an IC is going to have to plug in there. And I have to make sure that those connections to the IC are spread out the right space so that the part will slip right in there. Because I'm going to have to not only make the connections to it, but I have to drill holes out so I can put the part through the board. So you plan out those things. How far apart will all the connections be? Nowadays, it's super easy. You can get schematics off the internet. I used to get them out of books. You can put them into free computer programs, put in the schematic, and then say, give me a board layout. The computer will make this for you. And then, with that same free program, you can send that board design, this board layout, to a company that will make it for you and ship it to your house. So you can make your own custom circuit and have it professionally constructed and sent to your house. But I think it's more rewarding to build it yourself from scratch, and that's how I did mine. So the board layout is how it will actually look once constructed. You can see actual resistors, little cylinders, will sit right here, and the wires will go through the board. An IC will plug in right here, and the wires will go there. Over here, it's just symbols representing the parts. Here, the real thing will go in. Okay? Still with me? Okay, so we've gone from a schematic to a board layout. From there, now we got to turn it into reality. We got to plan the way it's actually going to look. But we have to transfer that over and make it out of metal. The whole idea of making a circuit board is to replace all these wires. They're not very reliable. We want to replace it with bits of copper. And if you look at a completed circuit board, like the one I'm going to show on the TV here, I guess I turned that off. Oh no, it's on. If you look at a completed circuit board, you will see that we have little copper connections for an IC here, for instance. All of this is for IC, and an IC goes through here. 4 wires there and 4 wires there. All of these other holes, hopefully it'll focus again. All these other holes here are for other connections. They could be resistors, they could be capacitors. These are little round jobbers. We call those donuts. We call these IC pads because they're kind of oval. And all the things that replace the wires, all of these lines, like you see here and here, those are called traces. They replace the wires. So in order to make these out of copper, what I do is I start with a piece of copper like this. Now it's not solid copper, it's actually copper on top of an insulator, some material that doesn't conduct electricity. They cover it with copper. When something's covered, you often say clad. Your feet are clad in shoes right now. This board is copper clad. It has a layer of copper on top of it. What I want to do is get rid of all the copper in here. I'm going to use acid to eat it away. Get rid of all the unwanted copper and leave only copper that matches my board layout. So for instance, here is a board layout for a circuit we used to make in here. This one right here. This is the plan. What I want to do is I want to somehow protect all the stuff I've drawn in black here. I want to protect that copper so that it doesn't get eaten away by the acid. By taking these things called transfers, etch-resist transfers, and rubbing them down to the board, everywhere you've got some of this black stuff, you're going to protect the board from the acid. It's going to keep it from being eaten away. How many understand what I'm explaining here? Good. So these little transfers, what we want to do is rub them down. They work kind of like rub-on tattoos. You know, you take the little sheet here and you put it down on top of the board and you use a pen from the other side and you rub it down and you transfer it over to the board. And wherever you got the little black things, it's going to protect that copper. All the other copper that's exposed will be eaten away by the acid. If you want to make wires, lines, you can cut these with an X-Acto knife to make them shorter and rub them down. You could even make little turns. But the ones that are the IC pads, those are going to be, you know, an oval shape with a hole in the middle. The donuts are going to be just what they sound like, with a hole in the middle. Eventually, the hole is where we're going to drill so that we can stick the wires for the part through. And the traces then are just the parts that the line, like these lines here, that connect the parts. They're going to replace the wires in our circuit, so we don't have those unreliable wires. Okay? All right, now here are some methods for doing this. I talked about the transfers. They take some time, but they give you nice, clean results, because after you rub them down, they make perfect little circles and all the little shapes perfectly. I used to give students this little transparency sheet so they could hold that over and they could check, okay, it needs to go right there. They'd lift it up, they'd put the transfer underneath, and then rub it down to make sure it went in the right spot. But it takes some time to do that. Now there's a shortcut method that's not nearly as nice. This would be like typing your report. If you want to handwrite it, you can use this etch-resist pen. It looks like a regular Sharpie, but it's special ink. And if I took this board right now and I just put, you know, a smiley face on it like that, and I stuck it in the acid, after it was done, I'd have a nice copper smiley face. And all the rest would be eaten away. Okay? So you could draw it by hand. In fact, some of the boards that I've had students do, I guess I don't have a sample here, they use that to put their initials on. Okay? Another method is they use special copper-clad boards that have been treated with a chemical. And this is kind of like what they do when they make them professionally. They use this sheet as a mask. They put this sheet over that specially treated board and they expose it to a special light. And everything that is exposed to that light will now be eaten away by the acid when we stick it in the acid. Everything that had that light blocked out won't be eaten away. So you just take this thing and you put it into the acid. So no matter what method you use to protect the board, the next step is to put it into the acid. The acid is hydrochloric, HCl. I know that looks like a 1, it's not. HCl, hydrochloric acid, like your stomach acid. Or it could be ferric chloride. This is ferric chloride and hydrochloric mixed. Kind of a brownish, reddish color. So what you're going to do is you take your board with all those little rub-on transfers on there and you stick it into the acid. It helps if you heat up the acid. It helps if you kind of rock the container back and forth as it's etching. But that's what we call that. Etching means to use that acid to eat away at the unwanted copper. So we're going to etch our boards. We're going to eat away at the unwanted copper. A couple facts I want you to know that will appear on the lab test. Fact number 1, when you put it into the acid, it will turn a dull red first. The copper will look not shiny copper color, but a dull red first. So you put it into the acid and you see it change to that dull red. And what will happen is it will begin to eat away at the copper from the edges first. It gets underneath that edge there. And you'll see the copper go away from the edges first. Now, if you leave it in too long, you'll see your little transfers, the little black pieces, will all come off the board, and it'll get ruined. And it's easy to do that, which is why we don't make circuit boards in here any longer, because it just took too long. But we used to do this. So you'll see the copper go away from the edges first, and it'll move more and more to the center, and you'll have a spot of copper left in the center. And eventually, when all that copper is gone from the center, you know it's ready. It's like the cake's done in the oven. You leave it in too long, you're going to ruin it. You take it out at the right time, and all you see now are those black transfers. Here comes my favorite part. You're going to go over to the sink, you're going to rinse it off. You're going to get some steel wool, which comes from steel sheep from Pittsburgh. They're very heavy sheep. They tend to fall over because of all the extra weight from their steel wool. Thank you. At least you show me you got my joke this time. Anyway, you're going to scrub that board, and all the black transfers are going to come off now, and you're going to be left with nice shiny copper in whatever shape you set it up to be. It should match your board layout now, okay? Obviously, this is just a copper-clad board, but it should look like this. The only thing left to do is to put holes where we have all the little dots, the donuts or the IC pads, and to put the parts on and attach them. That's where you guys are going to pick up. That's the part you're going to do. Okay? But again, to go back to the etching part, the etchant, you should know, is hydrochloric acid or ferric chloride. And that when we etch it, it's going to etch from the edges first. There's the test question about that. And there's also a question about the color. It will turn a dull red. It's the first color it will turn. All right. Now we're going to prepare the board for installing the parts. Every circuit board, and I'll point this out on yours as well, has two sides. It has a side that we do our connections on. We would call that the solder side. Do not pronounce the L. It's not solder or soldering. It's the solder side. So this is the side we're going to make our connections on. But the other side that has nothing on it right now is the side that we're going to put all the parts on. We call this the component side. It's the side we put the parts on. So the parts have to go through the board. The wires coming off the bottom of the parts have to go through the board. That means we're going to need to drill holes. The holes get drilled everywhere you see the little dots, everywhere you see the circles or the ovals. You're going to drill a hole right in the middle. You can use a little hand drill like I used to use, or you can use a Dremel tool like you see up there. You use these teeny tiny little bits and they break very easy if you're not careful. And you drill out all your little holes. And then the next part is, we call it stuffing the board. Basically taking the parts and sticking them through the board. You can actually get a job doing that. Putting components on the board. You don't even have to know what they do. You just put them in the right place in the right way. And then they use a machine to do all the soldering. It's called float soldering. We don't do that. We're going to do it the old-fashioned way. This is a soldering iron. I'm going to give you a whole lecture on how to solder, but for right now, soldering iron's job is to melt the solder. This is like your glue. Okay, so it's kind of like a hot glue gun, except Instead of glue, we use metal that we're going to melt. Instead of a glue gun, we use something similar to a curling iron but hotter. Smaller than some of the soldering guns you guys might have at home. Okay, but this little guy heats up the connection. So we put it right there on the connection and we heat up this solder. Everyone thinks this is wire. It is not. If it was wire, I couldn't just break off a piece like I just did there. I'm not that strong. It is two metals mixed together. We call it a alloy. We mix them together because we want both their properties. It used to be tin and lead. Now they don't use lead in solder as much because it's a bad metal. You know, it can cause problems. But it used to be tin and lead. And in the center of that solder, it's filled with a substance. Now you can't see here because it's too tiny, but it's hollow in the middle and it's filled with rosin. Who could tell me what rosin is?
Isn't that stuff that you put like on violins and stuff?
Yeah, you rosin a bow. Where else do you use rosin? Nobody else knows the other application.
Is it using like orthodontists and stuff?
I don't know. Maybe. I'm not familiar with that. It's used for baseball and softball players. Ever heard of a rosin bag? They shake it in their hand and they use this rosin. Rosin is basically tree sap, okay? You can see it clear on the rosin you use for your bow if you play the violin or cello or something like that. But it's basically tree sap. And what they do is they grind it up and they put it in a bag. You shake that bag and that powder comes out. It's like a whitish powder. And then you rub your hands together and it kind of melts and it gets really sticky. If you've ever leaned up against a tree with tree sap coming out, you know how sticky it is. And it's good for getting a grip on the bat or on the ball. Well, rosin in here helps that solder flow and stick. And that's why they put it in this kind of solder. This is called rosin core solder. There are other kinds of solder, but you wouldn't want to use them for electronics. Again, we'll talk more about that later on. So, in essence then, what we're going to have then, coming through these holes will be a wire. We use our solder, we hold it right there, and we heat up the connection, and that solder melts and makes a little puddle like you see on all of these connections. So we have a permanent connection. The last step is the wire is going to be longer and we're going to just clip off the extra wire. And you've got a completed circuit board. It's a lot more reliable. Okay? This circuit is not one you could go buy. This is a custom circuit made by me that I used back when my car ignition went out on me. I'd go to turn the key and it wouldn't work, and it was real expensive to pull off the steering wheel to fix it. So I figured I was just going to go around that, kind of like hot wire my own car. But I didn't want it so that anyone could come in and start the car. Head up, please. So what I did is I hooked up, this is a special touch switch. I hooked it up so that these two connections went to two pieces of metal in the car. And if I touched those two pieces of metal with my hands, a light would come on. It turned on a switch. And then I could push a little push button thing to start the car. And then when I wanted the engine to go off, I just touched two other different pieces of metal, like these two, and it would go off. And nobody knew how I was able to start or stop the car, turn the engine on or off. You could go push that button, unless you touched the magic two pieces of metal, it wouldn't work. It was pretty cool. I even sold the car that way, because I never did end up fixing the ignition. So you can do a lot with just a little bit of knowledge. Any questions on this? Okay, let me give you your little review. Well, actually, let's cover this and then I'll give you a quick review on the whole concept. We talked about this briefly already, but since ICs are used so frequently, I want you to remember these rules about ICs. First of all, ICs will either have a notch, like you see here, or a little dimple called the divot. Those two things will help you identify which connection is pin number 1. That particular IC has eight connections to it. If you hook up the wrong connections to the wrong thing, it isn't going to work. There's one right way of doing it. So you have to know that pin number 1 is going to be right here. If that's pin number 1, what pin number is this?
14.
You're right, this is 14, because you know that this is 8, and this is 7. We read across, then we go over this way and back the way we came. So that's the way they are numbered. If you put an IC in backwards, and it will go in backwards, it won't work. Some of you will do that with your IC, and you'll be like, my metal detector doesn't work, I did everything perfect. No, you didn't. One little mistake, you put the part in backwards, not going to work. Sometimes they use these guys here called IC sockets. It's not really an electronic part, it's just a holder for the IC. So you can put this in the board and attach it, and then if you accidentally damage this part, you can pop it out, you can put a new one in. We use these kinds of things, these sockets, all the time in computers. You want to add more memory, you plug it into the socket. You want to pull out the computer's brain and put a newer brain in, a newer CPU, you can plug it into the new socket. Okay? And even the socket will have a little notch on one end so you know which way you should put in the part, so it doesn't go in backwards. Okay? I also want you to know that there are two main enemies to an IC, two things that can destroy them. See if you can name either one. Well, water's not good for any electronics.
Fire.
Kind of. Heat. And where are you likely to expose it to excessive heat?
Short heat.
When you do what?
Oh, or like that.
No. How's it going to get excessive heat?
Oh, if you make a short circuit.
You think this might come into play at all?
Oh.
When you install the part, you overheat it by making your connection. You leave the soldering iron on too long, you can kill it. There are little microscopic parts inside with wires smaller than a human hair. They can be fried, they can be melted quite easily. The second way you can destroy it, a lot of them, not all of them, some are more durable than others, is static. Okay, static electricity, enough to have a spark jump from your finger to the wall, is enough to fry, to destroy parts inside. Okay, so that's why people that work in clean rooms where they make these things, they wear a strap that goes to from their wrist to a metal connection into the ground, so that they can never build up a static charge and destroy the parts. Okay, so those are the two enemies that you might see again later on the test: static and heat. So here's the quick review. To go from schematic to circuit board, first thing we have to do, get our shopping list. Buy the right parts. You have to be able to read the symbols, which I already taught you. Then you need to convert this to a board layout. Everywhere the dots are, you need to make sure those parts are connected. You plan it out on paper. You got to consider how far apart to make your connections, how big the parts are. You get your board layout, and you transfer it over to your copper-clad board. You can use transfers, you can use the special ink pen, you can use that photo method I talked about. Put it into the acid, etch off the unwanted copper. Scrub it clean with a steel wool, drill the holes out, put your parts through the opposite side, make your connection with rosin core solder. You use the IC socket. If you have an IC that you're afraid you might damage, you can always pop it out, put a new one in without having to rebuild the thing. Okay? So, you now have all those terms defined. I'm going to pass out some supplies to you, and I need you to follow my directions precisely at this point. First of all, you'll need to clear your desks of everything, because we're going to do this right at our seats. I'm going to give you a Ziploc bag. No. Bianca, you want to spit out your gum? Scotty, you want to move up? I need 3 of you that are really good at detailed stuff and paying attention, because you need to work some of these for people that aren't here today. Jeff? Oh, come on, Zach. You're too good.
Okay, I'll do it.
Zach, I need one more person. Thank you.
I don't think they take you.
You guys are doing 2 of these for the people that are gone today. All right, I'm going to give you a Sharpie. What I want you to do is write your first and last name on the outside of the bags, nice and big. Pass that Sharpie back. Okay? I'd like, Nathan, you can do Melissa. And Jeff, you can do, who's it? Rochelle? And you can do, wait, who's my third person? You can do Anthony.
Wait,
Okay, so you write down their first and last name, you write your first and last name on the bag, pass that Sharpie back. I'm going to give you your kit, do not open it yet. I'm going to give you specific instructions on that. All right, listen carefully. First, you might notice that the kit comes in an anti-static bag. That bag is conductive. The idea is if it's a piece of metal is not going to build up a static charge because the electrons just flow someplace else. That's to protect your IC in there so it doesn't get damaged. We're going to transfer our parts over to a Ziploc bag so that we can see everything in there and you got your name on it. This gets a little tight. So what I want you to do, when you do the work, you got little parts in there. Imagine that this has little tiny beads or balls in there, like ball bearings. You dump it out on your desk, they're going to go everywhere. So be prepared for that. Watch how I'm going to do this. This is what I would recommend to you guys. Oh, I didn't show you my different circuits. You have to remind me so I can show you those. So I'm going to cut the top of the bag real close to the end. And because if I do this higher up and drop it, things are going to bounce and go everywhere. I'm going to do it right near my desk, near the top of my desk. Just put it on my desk over there. And I'm going to dump it out with my hand cupped around it. Okay? I did that to keep the stuff from rolling away. Those of you that are doing 2, and you can turn that one over to Anthony. Those of you that are doing 2, you got to have to do 2 separate piles. Once you dump that out, then you can separate things up into things that look alike, like I did here. Some of the parts you can't see, but make it into little groupings like you see here, okay? Go ahead and cut the top off and do that. A lot of the parts are going to stick to a magnet on the inside. So just take that magnet, pull it off of the parts, separate everything out. Now, as you guys are working on that, I'll tell you about some of the other circuits that I have made over the years. It's neat to be able to take a schematic and go build something from scratch. And sometimes you can make stuff cheaper than you can buy it. Not so much today, but used to be the case. And sometimes you can't buy what it is you're looking for. The only way you're going to get it is by making it yourself. So I've made a number of things over the years. I was into car stereos, so I made this electronic crossover here that allows me to control what type of sounds go to which speakers in my car stereo. Made that for a fraction of what I could have bought one for. I was into robots for a while and wanted to have a voice-activated robot because I thought it'd be cool to be able to say, stop, go forward, turn right, and make the robot move to my voice. So for $5, I bought a little voice-activated integrated circuit. It did all that magic for me. Did I understand how or why it worked? No, not at all. But I could I could follow the schematic and build the circuit. So I made this box, and it has lights for each of the different directions. So I could say into a microphone, stop, reverse, turn right, and it would listen to certain parts of my words and try to identify them to control the robot's motion.
Did it work?
It did, but I looked like a total dork saying, stop, turn right, because you had to say it just right in order for it to work. So I didn't really go much farther with it. When I was teaching, I first was teaching PE. Remember the step test we did in here? Yeah, up, up, down, down. Well, I did it with kids in like the locker room. We had to step up and down on benches. This was at a different school. And I didn't want to sit there and call it out all period long like I did on the tape here with you guys. So I made my own little electronic metronome. Up, up, down, down, up, up, down, down. I got a schematic for something that was a timer, and I could control, I could adjust the timer and build it to do exactly what I wanted. So this is specifically for my needs. My favorite little invention that I made was actually the simplest, and it was again for my own needs. My friend was going to be traveling cross country. Again, you guys should be sorting these things all into piles of things that look alike. He was going to be traveling cross country, and I was concerned that he would fall asleep because he was driving alone. And he insisted on not stopping at a hotel and driving straight through like 20 hours, something ridiculous like that. So I went home and I made this thing, and I brought it back, and I got him to agree to use it for the trip. I took a pair of headphones, tore off one of the earpieces, the earphones, and then the other one I replaced with a buzzer. I attached a little battery pack and something called a mercury bulb. This is a tilt switch, so it closes the switch when it's tilted one way, opens it when it's tilted the other way. And all he had to do is put that on his head, and as he's driving down the road, if he starts to nod off, it would buzz whenever he dropped his head. I thought it was a pretty good idea. I call it the nodder. It kept him from getting in a car accident. I should have. Yeah, thank you for saying that, Zach. I wish you were around when I did that, because I didn't do anything with the idea. Many years later, I'm in a sharper image, and what do I see? A smaller version of what I had invented. They just scaled it down, got rid of the head strap, so it just stuck straight in your ear. They call it the Stay Awake Driver Alert. I like mine better, nodder. Okay? But my point is, you can make all sorts of things to suit your needs with just a little bit of knowledge. All right. Hopefully you got some basic piles there. What we're interested in dealing with right off the bat is this one, the circuit board. Okay? If you look up on the TV and examine your circuit board, you'll see that there is a component side. That's the side that has all the white outlines. It shows you where all the parts are going to go. The parts go through on this side. And then it has the other side. This is where you're going to make the connection. We call this the solder side. So make sure you understand when I say component side, I'm talking about the side with the little D on it. Okay? The other side is the solder side. You with me? What I need you to do now is on this side, the component side, the one with the D, right down here in this empty space, there's not a lot of it, use the Sharpie and put your 3 initials right down in this corner. Put your 3 initials there. Up here by the D, put a 4 for fourth period. Your initials down here and a 4 up here. Write that on with the Sharpie, then pass that back so everyone else can do it. I don't know her middle name, but MB.
What's her middle name?
What's Rochelle's last name?
Penix, P. Okay? So get the initials on there and the number 4 up there. And pass that Sharpie back. All right, as you're waiting for the Sharpie to come around, here's the next part I need everyone to do. You got your battery holder with a battery in there. It's wrapped in plastic. That's fine. We don't want to unwrap it yet. You might notice that it's stuck in the battery holder backwards. That's fine too. But what we want to do right now is take the battery out and look underneath, make sure there are no parts there. Sometimes parts get caught underneath. Next, you see how you have 6 long bolts and 2 short bolts? Take 4 of the long bolts and put them through on the inside of your battery holder. Put them through on the inside where you just took the battery out. That way the ends of those bolts will come out the same direction as the wire connections. Then you can put the battery back in the wrong way so that those things don't fall out when you flip it over. So it's not plugged in, just like you took it out. Put it back in the same way you took it out. That keeps those from falling out when you flip it upside down. Again, guys, when I say wrong way, that means you can see here at the end, you can see the connections on the battery. They shouldn't be covered up. All right, the next step is you should have 4. And if you don't have some of these things, you need to speak now, because if you say later, I don't have it, I'm going to say tough luck. I'm not going to ruin another $15 kit because you lost one of the parts. But you should have 4 of those white spacers here. 1, 2, 3, 4. You're going to put those on each of the 4 bolts you just put through the battery holder. 4 spacers. The white spacers. And then I think you know what comes next. This is the part where I would do it really close to the desk. You're going to carefully thread on those nuts, 1 on each of the bolts. Okay? Do it low and close to the table, because if you drop it, like Patrick just dropped something there, it's going to go away and you're going to be on your hands and knees crawling around trying to find it. If you squeeze on the side right by that bolt, it'll keep it from wobbling so much and it's a little easier to do. So put that on all 4 of the bolts. Just tighten it down until it doesn't wiggle any longer.
You got it?
Good. Once you've got that on, what I need you to do is bring this up and put it in the tray you see over here, and on the way you can throw out your anti-static bag and the little piece you cut off of it. So this goes over here. Anti-static bag and the top you cut off in the trash. This goes in the trash. Yep. So we've got that gone, that gone, that gone, that gone. All of those gone. And all these gone. You put that in the tray and you throw out the anti-static bag. You're not the only one to do that too, and I don't know why people are doing that. I didn't say anything about the circuit board going on there. No, you're not. I never said anything about that. Sit down, Anthony. All right, we have a number of other things we need to do, guys, and we're running out of time. So, Matt, you about done there? Okay, what you need to locate now are the remaining parts you see at the top there. You have two plastic pieces. One of them has a piece of white tape on it, the other one does not. You should have two remaining long bolts. You should have a button magnet. You should have two L brackets and two short bolts. Now, what I'd like you to do is find those L brackets. It may look like they're as long this way as they are this way. They are not. One side is long and one side is short. One side is long and one side is short. Examine your brackets, your L brackets, and determine which side is long and which side is short. The best clue you have of that is on the short side, the hole appears to be right in the middle. On the long side, the hole's not in the middle. Has everybody located the long side?
Yes.
Okay. What we want to do is take those short bolts and thread them through the short side. The short bolts go on the short side. So you hang on to the long side and you thread it through on the short side. The short bolts go through the short side. I'm sorry, I didn't explain that. Yes, it should be going from out here. Okay? So, if I'm holding the bracket like that in my hand, it's going on the outside, not from the inside. My mistake. So here's the short side here, and your bolt is going to go through that way. You don't thread it down all the way, guys. Just enough that it's in there. Doesn't have to be tightened down all the way. Just enough that it's in there. We're putting this stuff together because this is the stuff that's lost, and we're kind of assembling the bracket part. If you look up at the screen, you'll see what I mean on the completed one. This is a completed one here, and you can see the bracket. To focus here, you can see the bracket there is going to hold a magnet in the middle. And on the front of that is this other part that sticks to where the white tape currently is. But you see the L brackets in the back? They attach it to the circuit board. Okay? So we're going to just assemble this whole clamp part together right now so that it's ready to go when we get to that part and we don't lose things. So you got your two pieces of plastic. You notice that they both have a rough side and a smooth side, right? Put the rough sides so they face each other. The rough sides are facing towards each other, or touching each other. The rough sides are touching each other. I don't know how else to explain that. The rough sides are, they're touching each other. I mean, how else? The rough sides are against each other. They're touching each other. Okay? And the holes are lined up. Now, take your long bolts, the two remaining long bolts, and put them through on the side with the white tape. Put them through on the side with the white tape. Okay? Like so. Next, hold those bolts in there so that you can now take your brackets and thread them on a little bit onto each one of those bolts. Not all the way down, just a little bit. Take your brackets and thread them on to the bolts.
Yeah, does it matter which way they turn?
Well, they only go one direction.
No,
That's not what I mean.
in or out.
Don't want.
Wait, you know what I mean?
They're going to go... I understand what you're saying, okay? So, how do I show this? Like this, guys.
Just walk around the classroom. Or just be... Like that?
go through on the outside part of the bracket, not the inside part. They all go through on the outside part of the L. Everybody clear on this now?
Wait.
They look like chairs.
Yeah, with a screw
We're gonna run out of time here, guys. All right, the next part. I want you to take your button magnet and put it between the two pieces of plastic, right in there on the rough sides, remember? Between the two pieces of plastic. Then you can tighten those clamps down a little bit more, those L brackets, so that it holds that magnet in place between the two. Just turn them until it holds the magnet in there. I don't care which way the brackets go, as long as it holds it all together. Okay, so you got yourself a little sandwich now that holds that all that stuff together. The next part is to put all the remaining parts, keep the bracket out that you just put together, put all the remaining parts back in your bag that you labeled, including the board. Be careful you don't lose anything. Including your circuit board. So you got your labeled bag, your labeled board, and all the remaining parts, and you got your magnet clamp thingy here. The bag goes in one of these trays, the clamp thingy goes in the little cup. When you've done that, you are all done.